equations, if they exist, by the method of completing the square. I, 2x7x plus 3 equals 0. E, 2x plus x4 equals 0. E, 4x plus 4 square root 3x plus 3 equals 0. IV, 2x plus x plus 4 equals 0. Solutions. I, 2x7x plus 3 equals 0. 2x7x equals 3. Dividing by 2 on both sides, we get x minus 7x, 2 equals minus 3 halves. x2 times x times 7 quarters equals minus 3 halves. On adding 7 quarters to both sides of the equation, we get x minus 2 times x times 7 quarters plus 7 quarters equals 7 quarters minus 3 halves. By 7 quarters equals 49 sixteenths, 3 halves. By 7 quarters equals 25 sixteenths. By 7 quarters equals plus or minus 5 quarters. X equals 7 quarters plus or minus 5 quarters. X equals 7 quarters plus 5 quarters, or x equals 7 quarters to 5 quarters. X equals 12 quarters, or x equals 2 quarters. X equals 3, or x equals 1 half. E, 2x plus x4 equals 0. 2x plus x equals 4. Dividing both sides of the equation by 2, we get x plus x, 2 equals 2. Now on adding 1 quarter to both sides of the equation, we get x plus 2 times x times 1 quarter plus 1 quarter equals 2 plus 1 quarter. X plus 1 quarter equals 33 sixteenths. X plus 1 quarter equals plus or minus square root 33 quarters. X equals plus or minus square root 33 quarters to 1 quarter. X equals plus or minus square root 33 to 1, 4. Therefore, either x equals square root 33 to 1, 4, or x equals square root 33 to 1, 4. E, 4x plus 4 square root 3x plus 3 equals 0. Converting the equation into a plus 2ab plus b form, we get 2x plus 2 times 2x times square root 3 plus square root 3 equals 0. 2x plus square root 3 equals 0. 2x plus square root 3 equals 0 and 2x plus square root 3 equals 0. Therefore, either x equals square root 3 halves or x equals square root 3 halves. IV, 2x plus x plus 4 equals 0. 2x plus x equals minus 4. Dividing both sides of the equation by 2, we get x plus 1 half x equals 2. X plus 2 times x times 1 quarter equals minus 2. By adding 1 quarter to both sides of the equation, we get x plus 2 times x times 1 quarter plus 1 quarter equals 1 quarter 2. X plus 1 quarter equals 1/16 2. X plus 1 quarter equals minus 31/16. As we know, the square of numbers cannot be negative. Therefore, there is no real root for the given equation. 2x plus x plus 4 equals 0. 2. Find the roots of the quadratic equations given in Q.1 above by applying the quadratic formula. I, 2x7x plus 3 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals minus 7 and c equals 3. By using the quadratic formula, we get x equals 7 plus or minus square root 49 to 24, 4. X equals 7 plus or minus square root 25, 4. X equals 7 plus or minus 5, 4. X equals 7 plus 5, 4 or x equals 7 to 5, 4. X equals 12 quarters or 2 quarters. Therefore x equals 3 or 1 half. 2x plus x4 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals 1 and c equals minus 4. By using the quadratic formula, we get x equals minus 1 plus or minus square root 1 plus 32, 4. X equals minus 1 plus or minus square root 33, 4. Therefore x equals minus 1 plus square root 33, 4 or x equals minus 1 square root 33, 4. 4x plus 4 square root 3x plus 3 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 4, b equals 4 square root 3 and c equals 3. By using the quadratic formula, we get x equals minus 4 square root 3 plus or minus square root 48 to 48, 8. X equals minus 4 square root 3 plus or minus 0, 8. Therefore x equals square root 3 halves or x equals square root 3 halves. IV 2x plus x plus 4 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals 1 and c equals 4. By using the quadratic formula, we get x equals minus 1 plus or minus square root 1 to 32, 4. X equals minus 1 plus or minus square root minus 31, 4. As we know, the square of a number can never be negative. Therefore, there is no real solution for the given equation. 3. Find the roots of the following equations. I, x1, x equals 3, x does not equal 0. 1, x plus 4, 1, x7 equals 11/30, x equals minus 4, 7. Solution. I, x1, x equals 3. x3 times minus 1 equals 0. On comparing the given equation with x plus bx plus c equals 0, we get a equals 1, b equals minus 3 and c equals minus 1. By using the quadratic formula, we get x equals 3 plus or minus square root 9 plus 4, 2. X equals 3 plus or minus square root 13, 2. Therefore x equals 3 plus square root 13, 2 or x equals 3 square root 13, 2. 1, x plus 4, 1, x7 equals 11/30. x7 x minus 4, x plus 4, x7 equals 11/30. Minus 11, x plus 4, x7 equals 11/30. X plus 4, x7 equals minus 30. x3 x28 equals 30. x3 x plus 2 equals 0. We can solve this equation by factorization method now. x2 x plus 2 equals 0. x2 1 x2 equals 0. x2 x1 equals 0. X equals 1 or 2. 4. The sum of the reciprocals of Raymond's age, in years, 3 years ago and 5 years from now is 1/3. Find his present age. Solution. Let us say the present age of Rahman is X years. 3 years ago, Raymond's age was X3 years. 5 years after, his age will be X plus 5 years. Given the sum of the reciprocals of Raymond's ages 3 years ago and after 5 years is equal to 1/3. Therefore 1, x3 plus 1, x5 equals 1/3. X plus 5 plus x3, x plus 5 equals 1/3. 2x plus 2, x3, x plus 5 equals 1/3. 3, 2x plus 2 equals x3, x plus 5. 6x plus 6 equals x plus 2x 15. x4 x21 equals 0. x7 x plus 3 x21 equals 0. x7 plus 3 x7 equals 0. x7 x plus 3 equals 0. X equals 7 minus 3. As we know, age cannot be negative. Therefore, Raman's present age is 7 years. 5. In a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the 2 subjects. Solution. Let us say the marks of Shefali in maths be x. Then, the marks in English will be 30x. As per the given question, x plus 2, 30x3 equals 210. X plus 2, 27x equals 210. X plus 25x plus 54 equals 210. X25x plus 156 equals 0. X12x13x plus 156 equals 0. X12 minus 13 x12 equals 0. x12 x13 equals 0. X equals 12, 13. Therefore, if the marks in maths are 12, then marks in English will be 30 minus 12 equals 18, and if the marks in maths are 13, then marks in English will be 30 minus 13 equals 17. 6. The diagonal of a rectangular field is 60 meters more than the shorter side. If the longer side is 30 meters more than the shorter side, find the sides of the field. Solution. Let us say the shorter side of the rectangle is xm. Then, larger side of the rectangle equals x plus 3om. As given, the length of the diagonal is equals x plus 30 meters. Therefore, x plus 3o equals x plus 6o. x plus 900 plus 60x equals x plus 3600 plus 120x. X 60 x 2700 equals 0. X 90 x plus 30 x 2700 equals 0. X 90 plus 30 x minus 90 equals 0. X 90 x plus 30 equals 0. X equals 90 minus 30. However, the side of the field cannot be negative. Therefore, the length of the shorter side will be 90 meters. And the length of the larger side will be 90 plus 30 m equals 120 meters. 7. The difference of the squares of two numbers is 180. The square of the smaller number is 8 times the larger number. Find the two numbers. Solution. Let us say the larger and smaller number be x and y, respectively. As per the question given, xy equals 180 and y equals 8x 180 equals 0. X 18 x plus 10 x 180 equals 0. X 18 plus 10 x 18 equals 0. X 18 x plus 10 equals 0. X equals 18 minus 10. However, the larger number cannot be considered a negative number, as 8 times the larger number will be negative, and hence, the square of the smaller number will be negative, which is not possible. Therefore, the larger number will be 18 only. X equals 18. Therefore, y equals 8x equals 8 times 18 equals 144. Y equals plus or minus square root 144 equals plus or minus 12. Therefore, smaller number equals plus or minus 12. Therefore, the numbers are 18 and 12 or 18 and minus 12. 8. A train travels 360 kilometers at a uniform speed. If the speed had been 5 kilometers per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. Solution. It is given that distance equals 360 kilometers. Consider x as the speed, then the time taken. T equals 360 x. If the speed is increased by 5 kilometers per hour, the speed will be x plus 5 km per hour. Distance will be the same. T equals 360 x plus 5. We know that time with original speed, time with increased speed equals 1. 360 x 360 x plus 5 equals 1. LCM equals x plus 5. 360 x plus 5 360 x plus 5 equals 1. 360 x plus 1800 360 x equals x plus 5. X plus 5x equals 1800. X plus 5x 1800 equals 0. X plus 45x 40x 1800 equals 0. X plus 45 40 x plus 45 equals 0. X 40 x plus 45 equals 0. X equals 40 kilometers per hour. As we know, the value of speed cannot be negative. Therefore, the speed of the train is 40 kilometers per hour. 9. Two water taps together can fill a tank in hours. The tap of a larger diameter takes 10 hours less than the smaller one to fill the tank separately. Find the time at which each tap can separately fill the tank. Solution. Let the time taken by the smaller pipe to fill the tank equals XHR. Time taken by the larger pipe equals X10 HR. Part of the tank filled by smaller pipe in 1 hour equals 1 X. Part of the tank filled by larger pipe in 1 hour equals 1 X10. As given, the tank can be filled in equals 75/8 of an hour by both the pipes together. Therefore, 1 X plus 1 X10 equals 8/75. X10 plus X X10 equals 8/75. 2 by minus 10 X10 equals 8/75. 75 2x10 equals 8x80x. 150x 750 equals 8x80x. 8x 230x plus 750 equals 0. 8x 200x 30x plus 750 equals 0. 8x x 25 minus 30 x 25 equals 0. X 25 8 by minus 30 equals 0. X equals 25 38. Time taken by the smaller pipe cannot be 30 divided by 8 equals 3.75 hours, as the time taken by the larger pipe will become negative, which is logically not possible. Therefore, the time taken individually by the smaller pipe and the larger pipe will be 25 and 25 minus 10 equals 15 hours, respectively. 10. An express train takes 1 hour less than a passenger train to travel 132 kilometers between Mysore and Bangalore, without taking into consideration the time they stop at intermediate stations. If the average speed of the express train is 11 kilometers per hour more than that of the passenger train, find the average speed of the two trains. Solution. Let us say the average speed of the passenger train equals by kilometer per hour. Average speed of express train equals x plus 11 kilometer per hour. Given the time taken by the express train to cover 132 kilometers is 1 hour less than the passenger train to cover the same distance. Therefore, 132 x 132 x plus 11 equals 1. 132 x plus 11 x x plus 11 equals 1. 132 times 11 x plus 11 equals 1. 132 times 11 equals x plus 11. X plus 11 x 1452 equals 0. X plus 44 x minus 33 times minus 1452 equals 0. X plus 44 minus 33 x plus 44 equals 0. X plus 44 x 33 equals 0. X equals 44 33. As we know, speed cannot be negative. Therefore, the speed of the passenger train will be 33 kilometers per hour, and thus, the speed of the express train will be 33 plus 11 equals 44 kilometers per hour. 11. Sum of the areas of two squares is 468 meters. If the difference between their perimeters is 24 meters, find the sides of the two squares. Solution. Let the sides of the two squares be xm and ym. Therefore, their perimeter will be 4x and 4y, respectively. And the area of the squares will be x and y, respectively. Given 4x 4y equals 24. X, y equals 6. X equals y plus 6. Also, x plus y equals 468. 6 plus y equals 468. 36 plus y plus 12y plus y equals 468. 2y plus 12y plus 432 equals 0. Y plus 6y 216 equals 0. Y plus 18y 12y 216 equals 0. Y plus 1 8 minus 12 y plus 18 equals 0. Y plus 18 y 12 equals 0. Y equals minus 18, 12. As we know, the side of a square cannot be negative. Hence, the sides of the squares are 12 meters and 12 plus 6, m equals 18 meters. Exercise 4.4 page 91. 1. Find the nature of the roots of the following quadratic equations. If the real roots exist, find them. I, 2x 3x plus 5 equals 0. E, 3x4 square root 3x plus 4 equals 0. E, 2x6 x plus 3 equals 0. Solutions. I, given 2x 3x plus 5 equals 0. Comparing the equation with x plus bx plus c equals 0, we get A equals 2, b equals minus 3 and c equals 5. We know discriminant equals b4ac equals 3, 4, 2, 5 equals 9 to 40 equals 31. As you can see, b4ac less than 0. Therefore, no real root is possible for the given equation 2x 3x plus 5 equals 0. E, 3x4 square root 3x plus 4 equals 0. Comparing the equation with x plus bx plus c equals 0, we get A equals 3, b equals minus 4 square root 3 and c equals 4. We know discriminant equals b4ac equals minus 4 square root 3, 4, 3, 4 equals 48 minus 48 equals 0. As b4ac equals 0. Real roots exist for the given equation and they are equal to each other. Hence, the roots will be b, 2a and b, 2a. b, 2a equals minus 4 square root 3, 2 times 3 equals 4 square root 3 divided by 6 equals 2 square root 3 divided by 3 equals 2 square root 3. Therefore, the roots are 2 square root 3 into square root 3. E, 2x6x plus 3 equals 0. Comparing the equation with x plus bx plus c equals 0, we get A equals 2, b equals minus 6, c equals 3. As we know, discriminant equals b4ac equals minus 6, 4, 2, 3 equals 36 minus 24 equals 12. As b4ac greater than 0. Therefore, there are distinct real roots that exist for this equation 2x6x plus 3 equals 0 equals minus 6 plus or minus square root 6 to 4, 2, 3, 2, 2 equals 6 plus or minus 2 square root 3, 4 equals 3 plus or minus square root 3, 2. Therefore, the roots for the given equation are 3 plus square root 3, 2 and 3 square root 3, 2. 2. Find the values of k for each of the following quadratic equations so that they have two equal roots. I, 2x plus kx plus 3 equals 0. E, kx, x2 plus 6 equals 0. Solutions. I, 2x plus kx plus 3 equals 0. Comparing the given equation with x plus bx plus c equals 0, we get a equals 2, b equals k and c equals 3. As we know, discriminant equals b for ac. Equals k, 4, 2, 3. Equals k 24. For equal roots, we know discriminant equals 0. K 24 equals 0. K equals 24. K equals plus or minus square root 24 equals plus or minus 2 square root 6. E, kx, x2 plus 6 equals 0. Or kx2 kx plus 6 equals 0. Comparing the given equation with x plus bx plus c equals 0, we get a equals k, b equals 2k and c equals 6. We know discriminant equals b for ac. Equals 2k, 4k, 6. Equals 4k 24k. For equal roots, we know b for ac equals 0. 4k 24k equals 0. 4k, k6 equals 0. Either 4k equals 0 or k equals 6 equals 0. K equals 0 or k equals 6. However, if k equals 0, then the equation will not have the terms x and x. Therefore, if this equation has two equal roots, k should be 6 only. 3. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters? If so, find its length and breadth. Solution. Let the breadth of the mango grove be L. The length of the mango grove will be 2L. Area of the mango grove equals 2L, L equals 2L. 2L equals 800. L equals 800 halves equals 400. L 400 equals 0. Comparing the given equation with x plus bx plus c equals 0, we get a equals 1, b equals 0, c equals 400. As we know, discriminant equals b for ac. Equals greater than 0, 4 times 1 times 400 equals 1600. Here, b for ac greater than 0. Thus, the equation will have real roots, and hence, the desired rectangular mango grove can be designed. L equals plus or minus 20. As we know, the value of length cannot be negative. Therefore, the breadth of the mango grove equals 20 meters. Length of mango grove equals 2 times 20 equals 40 meters. 4. Is the following situation possible? If so, determine their present ages. The sum of the ages of two friends is 20 years. 4 years ago, the product of their age in years was 48. Solution. Let's say the age of one friend is x years. Then, the age of the other friend will be 20x years. 4 years ago. Age of first friend equals x 4 years. Age of second friend equals 20x 4 equals 16x years. As per the given question, we can write x4, 16x equals 48. 16x, x 64 plus 4x equals 48. X plus 20x 112 equals 0. X 20x plus 112 equals 0. Comparing the equation with x plus bx plus c equals 0, we get a equals 1, b equals minus 20 and c equals 112. Discriminant equals b4ac equals minus 20, 4 times 112 equals 400 minus 448 equals minus 48. b4ac less than 0. Therefore, there will be no real solution possible for the equations. Hence, the condition doesn't exist. 5. Is it possible to design a rectangular park of perimeter 80 and an area of 400 square meters? If so, find its length and breadth. Solution. Let the length and breadth of the park be L and B. Perimeter of the rectangular park equals 2, L plus B equals 80. So, L plus B equals 40. Or B equals 40L. Area of the rectangular park equals L times B equals L, 40L equals 40L, L equals 400. L 40L plus 400 equals 0, which is a quadratic equation. Comparing the equation with x plus bx plus c equals 0, we get a equals 1, b equals minus 40, c equals 400. Since discriminant equals b4ac equals minus 40, 4 times 400 equals 1600 minus 1600 equals 0. Thus, b4ac equals 0. Therefore, this equation has equal real roots. Hence, the situation is possible. The root of the equation L equals b, 2a. L equals minus 40, 2, 1 equals 40 halves equals 20. Therefore, the length of the rectangular park L equals 20 meters. And the breadth of the park B equals 40, L equals 40 minus 20 equals 20 meters. NCERT Solutions for Class 10 Maths Chapter 4 Quadratic Equations. A 1-mark question was asked from Chapter 4 Quadratic Equations in the year 2018. However, in the year 2017, a total of 13 marks were asked from the topic Quadratic Equations. Therefore, students need to have a thorough understanding of the topic. The topics and subtopics provided in this chapter include 4.1 Introduction. If we equate the polynomial x plus bx plus c, a does not equal 0 to 0, we get a quadratic equation. Quadratic equations come up when we deal with many real-life situations. In this chapter, students will study quadratic equations and various ways of finding their roots. They will also see some applications of quadratic equations in daily life situations. 4.2 Quadratic Equations. A quadratic equation in the variable x is an equation of the form x plus bx plus c equals 0, where a, b, c are real numbers, or does not equal 0. In fact, any equation of the form p, x, equals 0, where p, x, is a polynomial of degree 2, is a quadratic equation. But when we write the terms of p, x, in descending order of their degrees, then we get the standard form of the equation. That is, X plus bx plus c equals 0, or does not equal 0 is called the standard form of a quadratic equation. 4.3 Solution of quadratic equations by factorization. A real number alpha is called the root of the quadratic equation x plus bx plus c equals 0, or does not equal 0 if alpha plus b alpha plus c equals 0. We also say that x equals alpha is a solution of the quadratic equation, or that alpha satisfies the quadratic equation. Note that the zeros of the quadratic polynomial x plus bx plus c in the roots of the quadratic equation x plus bx plus c equals 0 are the same. 4.4 Solution of a quadratic equation by completing the square. Finding the value that makes a quadratic equation a squared trinomial is called completing the square. The squared trinomial can then be solved easily by factorizing. 4.5 Nature of roots. If b4ac less than 0, then there is no real number whose square is b4ac. Therefore, there are no real roots for the given quadratic equation in this case. Since b4ac determines whether the quadratic equation x plus bx plus c equals 0 has real roots or not, b4ac is called the discriminant of this quadratic equation. So, a quadratic equation x plus bx plus c equals 0 has I. Two distinct real roots, if b4ac greater than 0, e. Two equal real roots, if b4ac equals 0, e. No real roots, if b4ac less than 0. 4.6 Summary.